Here's a question that should have a simple answer. What number multiplied by itself gives you -1? Let's try. So 2 times 2 is 4. -2 times -2 is also 4. A positive times a positive is a positive, and a negative times a negative is also a positive. So whatever number you pick on this line, squaring it always lands you on the positive side, which means there's nowhere on this entire line for the square root of -1 to live. For centuries, that was the end of the story. The answer simply didn't exist until someone refused to accept that. Eventually, mathematicians did something audacious. They said, fine, if no number works, we'll invent one. Call it I, defined as the square root of -1. And they gave it a name that was actually meant as an insult, imaginary. They coined it to mock the whole idea. These weren't real numbers, they said, just convenient fictions. Useful, maybe, but not real. Well, actually, hold on to that word, because by the end of this video, imaginary numbers are going to feel as solid as any number you've ever counted with. The first crack in the supposedly not real story came from a problem that nobody could dodge. See, in the 1500s, mathematicians had a single formula that could crack any cubic equation until they hit one exactly like this one. And this equation has a perfectly ordinary, perfectly real answer. X equals 4. Check it. 4 cubed is 64. 15 fourths plus 4 is 64 too. It works. But run it through the only formula they had, and this falls out. Look at the middle. The square root of -121. There it is again. The square root of a negative number. The thing that supposedly doesn't exist. And yet the only path to that sensible answer of 4 runs straight through it. The imaginary parts show up, do their work, and cancel out perfectly, leaving 4 behind. You couldn't reach the real answer without passing through the impossible one. And that should make you suspicious. Maybe these numbers aren't fictions. Maybe we just hadn't worked out what they actually are. So, let's actually work it out. Here's the trouble. All our familiar numbers, like 1, 2, 3, and so on, live on a singular line. And there's no more space left on it. So, we do the only thing we can. We stop picturing the numbers on a line, and we start picturing them on a plane. X and Y axis, and the old number line stays exactly where it is, from left to right, but we add a brand new direction, up and down. That vertical direction is where I lives, one step up from 0. Now every number is a place. 2 plus I, 2 steps right, 1 step up. This is the complex plane, and every complex number is just a point on it. Now let's look at the part that changes absolutely everything. On this plane, what does multiplying by I actually do? Start at 1, multiply by I, and watch. It doesn't grow, it doesn't shrink, it turns exactly 90 degrees. Multiply by I again, you have another quarter turn. And look where we land, -1. That's the whole secret, really. I times I is -1. 2 quarter turns makes a half turn, and a half turn from 1 lands you on -1. It's not a trick, it's just what rotation does. And if you keep going, another turn, we're back where we started. 4 multiplications by I take you all the way around. And as you can see, it isn't only the number 1. Take any point, 2 plus I, multiply it by I, and the whole thing pivots 90 degrees. Multiplying by I rotates the entire plane. That is what I is, a rotation. And once you see I as rotation, something beautiful falls out. If 1 multiplication by I is a quarter turn, what does continuous rotation look like? Like this, a point sweeping around the unit circle, and the formula for it ties together 2 things you'd never expect to meet. E, Euler's number, the number from the last video, and rotation itself. Send that point exactly halfway around, an angle of pi, and where does it land? -1. So e to the power of I pi equals -1. Rearrange and you get the most famous equation in all of maths. E to the I pi plus 1 equals 0. Last video it was just a teaser, now you can see it. It's nothing more than a half turn around a circle. So imaginary numbers are rotation, and I'm about to show you why that makes them indispensable. What's the shadow of a spinning point? As it goes round, its height traces out a wave. Rotation, seen from the side, is oscillation. They're the same thing. And oscillation is everywhere. The alternating current in every plug in your home. Engineers model it as a spinning point in the complex plane. Every sound wave, every light wave, every signal your phone sends, taken apart into rotations. And in quantum mechanics, the wave function that governs reality at its deepest level has I built right into it. Not as a fiction, as the only language that works. So let's go back to that word, imaginary. It was never the right name. These numbers aren't imaginary at all. They're rotation. I is simply a 90-degree turn. That's the entire idea. Imaginary numbers are the algebra of rotation, and rotation is about as real as it gets. Okay, so step back and look at what just happened. A number was never only a point on a line. It can be a point in a plane with a direction, with the power to turn other numbers. Impossible turned out to be a failure of imagination. The answer was real the whole time. It was just waiting one dimension up. And for me, this provokes another thought. If going from a line to a plane unlocked all of this, what happens if we move one dimension further? There are 4-dimensional numbers called quaternions that rotate 3-dimensional space. They steer spacecraft and animate every video game you've ever played. But that's a story for another day.